Today, there are over 25.
But most of that energy comes from burning coal, oil, and gas.
I don't think people understand when they flip the light switch where that energy comes from.
Is there a better way?
We need a miracle in energy technology.
Around the globe, there is a race on to find solutions. Tapping the power of the sun.
This tablespoon of fuel is going to change the world.
Cleaning up coal.
We need to innovate faster.
And in the wake of Japan's tsunami, re-examining nuclear.
Nuclear keeps looking pretty good, even with Fukushima in mind.
Can technology help us fuel our future?
The carbon problem is actually easily solvable.
And are we ready for it?
Everybody wants it somewhere other than their own backyard. Guess what? If you don't solve the problem, your backyard isn't going to look the same anyway.
Up now, on Nova, Power Surge. Most programs about climate change start on a note of doom, with images like this, or even this. But this is a program about fixing it. So it starts in a place where it is hard to imagine that there are any problems at all. Sir Richard Branson's private Caribbean island.
When I first saw this island, I'd never seen a more beautiful jewel in my life and completely fell in love with it. The challenge was to make sure that you actually enhanced its beauty rather than destroy it.
Branson, the airline mogul, has even upgraded his little Caribbean jewel with some pretty spectacular flyers.
About 100 years ago, I think the last flamingo got eaten. So we've embarked on a program of reintroducing them to the islands. I think the island is a more perfect island today than it was before we arrived. And I think, that's what we've got to try to do with the world.
But fixing the world isn't easy, even for billionaires. In fact, Branson's love of nature has created a big personal dilemma. He's become super rich while bringing stylish air travel to the masses. And yet, he is also worried about climate change. Those two passions are like the oil it takes to run his planes and water. They do not mix. Branson's dilemma, while a bit more high-flying than most, is ultimately the same that we all face. How can we get the energy our world needs in a way that won't threaten it?
Climate change is one of the greatest threats to development.
Branson's solution is to use his entrepreneurial muscle and profits to attack climate change. An idea inspired by another famous Brit, Winston Churchill.
The threat of carbon could be worse than World War I, World War II put together. If that were the case, Churchill would get a war room set up and he would rally industry, he'd rally the troops and try to beat carbon, the enemy. And so we set up the carbon war room.
Branson is not alone. Right now, in laboratories around the globe, there is a race on to find solutions. The outcome is uncertain. But ultimately, the question is, can technology save us from climate change? Power Surge investigates those solutions. There is no better place to start than deep in this West Virginia coal mine. Coal, which generates half of all U.S. electricity, tells a story millions of years old. 35 million years ago, Earth's atmosphere was awash in carbon dioxide. But this is what Earth looked like. Alligators in South Dakota, palm trees in the Rocky Mountains, and instead of being covered by ice, there were forests in Antarctica. Over millions of years, those trees pulled the carbon out of the air to grow. And when they died, much of that carbon got buried underground. The same process created the coal we see here in West Virginia. Coal is up to 86% carbon. A gallon of gasoline, another fossil fuel, represents 100 tons of ancient plants. That's why gas, coal, and oil are called fossil fuels. With the advent of the industrial age, that carbon-rich coal and oil was dug up and burned as fuel. Burning anything releases carbon. But carbon-dense coal and oil release a lot. That carbon, long buried, combines with oxygen in the Earth's atmosphere and acts like a blanket, trapping heat. This NASA map shows global temperatures rising over the last century. No one is sure precisely how much the temperature will rise, or how quickly. But the atmospheric carbon predicted for the end of this century is approaching the level from 35 million years ago, when those alligators swam in South Dakota. The task ahead is to cut carbon emissions. And that is exactly what Stephen Pacala has figured out how to do. Pacala is an environmental biologist at Princeton University and a serious woodworker. He has used both skills to demonstrate how we can solve our carbon problem. He calls it the wedge theory.
It's easy to say, oh, the energy problem is so big that we can't possibly build enough wind turbines to solve it. We can't possibly do enough conservation to solve it. So you break the problem into pieces and say, what are the technological options across the board that we have to throw at it?
Pacala says the problem can be easily visualized.
This is the amount of emissions that humanity puts out annually. That's carbon emissions, greenhouse gas emissions. And this is time. And what happened for the first 10,000 years since the end of the last ice age, people emitted almost nothing. Just a little bit associated with farming. But then the Industrial Revolution happened, and emissions started to increase because of the burning of coal and then oil and then natural gas. And they've increased and increased and increased, and they're still increasing today. Instead of allowing them to climb, we've got to freeze them. And so this triangle here is the size of the problem. It's the gap between what we're going to do and what we must do.
Pacala says this triangle represents the challenge. It is the carbon emissions that we must somehow keep out of the atmosphere. To help make this easier to understand, and more fun, Pacala decided to turn it into a game, literally.
One Christmas I was at home and my kids were fighting inside about something, and I decided I was going to go outside and build something.
He used his woodworking skills to build the wedges game. Here's how it works. He turned the area that is the problem into a triangle. This represents the total amount of carbon dioxide we must avoid putting into the atmosphere in the next 50 years. The ideal target is controversial. Pacala calculated it was 7 billion tons per year. He divided that up into 1 billion ton sections. Next, he made wood wedges that represent technologies that could fill in that triangle.
We said, is there any technology big enough to do 1/7 of the problem? And the answer was, lo and behold, there were 15 already in the marketplace at an industrial scale. These are not pie in the sky things. These are things you can go and visit on a field trip.
Most of the 15 wedges can be grouped into 4 simple categories. This green wedge represents the easiest and cheapest, efficiency. Like increasing the fuel mileage of all cars from 30 to 60 miles per gallon. This yellow wedge represents tripling the number of nuclear power plants over 50 years. This blue wedge represents cleaning coal plants by burying their carbon emissions. And this red wedge represents the sun, harnessing its power with solar panels or wind turbines.
This thing has 2 different wedges in it.
Pacala and his Princeton colleague, Robert Socolow, did the complicated analysis behind this simple game to prove that it could be done. The way you play the game is to fill the triangle with 7 of the 15 available technological wedges and create your own solution to the climate crisis. Some people might use more solar energy. Others, more efficiency savings.
I'm going to nominate a wedge of efficiency.
And I think efficiency, 1 wedge is modest. And so if we put in 2 more of these nice green efficiency wedges.
The point is that there are many possible solutions. It all depends on our choices. Drawing the blueprint for a solution to this problem is deeply challenging. To help, NOVA has assembled a panel of experts, leaders from business, academia, and government, who are all trying to find solutions.
Can technology save us? Yes, it can, and it should, it must. And that's the thing, it must save us.
Can technology save us from climate change? Absolutely. I'm very convinced that it can. And in fact, beyond that, what I would say is it's an incredible opportunity for us to create all kinds of new things.
I know we can do things that we can't dream of today. We can't envision what it will look like 100 years from now.
I think the carbon problem is actually easily solvable. What's hard is that we need to make a lot of change in a hurry. We more or less have the coming 4 decades to recreate a green version of the Industrial Revolution that's taken us 150 years.
There are people right now who go to work every day and they can say to themselves, you know, if I get lucky today, I will arguably save the world and become not just the richest person in it, but the richest person ever.
Climate change solutions will create more wealth than any other sector over the next decade.
Richard Branson knows the power of profits to spark innovation. So he has started a $25 million contest for the best idea to reduce carbon levels.
Is there some way that some of that extra CO2 might be scavenged efficiently out of the atmosphere?
One of the people working to do that, and hoping that Branson might make his Christmas come a bit early, is Klaus Lackner, a physicist at Columbia University. Lackner's idea is brilliantly simple. Why not develop technologies that work just like trees, removing the carbon pollution that our cars and Branson's planes make?
Everybody knows it can be done. Every submarine has to pull that CO2 out of the air people breathe inside.
Carbon capture is not a new idea. The Navy has relied on it for decades. Deep underwater, submariners exhale carbon dioxide with every breath. In such a small, enclosed space, that CO2 builds up and becomes toxic. In every submarine, the CO2 must be removed from the air for the sailors to survive. That's done with some pretty basic chemistry, using a machine called a scrubber. The carbon in a carbon dioxide molecule has a slight positive charge. If the chemical filter inside the scrubber has a special negative charge, the carbon dioxide will be drawn to it like a magnet. In his lab, Lackner found a resin-based material that acts just like the submarine scrubber, attracting carbon dioxide to stick to it. The next challenge was how to capture carbon naturally in the breeze, without using energy. Lackner experimented with various shapes, from rigid flat panels to material draped like a flag. He discovered that cutting the material into very thin strips and putting them along a wire would be most effective. The result, a man-made carbon collector, highly engineered at one of America's top universities that looks, in the end, like a branch of a Christmas tree.
These two branches look very much alike because they functionally try to do more or less the same thing. But these materials are about 1,000 times better at collecting CO2 from the air than a natural tree is.
Lackner's vision is that one day there would be a fleet of carbon-eating vehicles, each about the size of an 18-wheeler, sucking up the unwanted carbon from Richard Branson's planes or those New York City cabs. Our modern world has an insatiable appetite for energy. It is tied to economic growth and prosperity. Currently, fossil fuels feed 85% of that demand.
It's very difficult to solve the climate change problem without having some component where fossil fuels are still used and we are taking the CO2 and capture it and store it safely and permanently.
Coal is really critical, not just because 50% of electricity comes from coal in the U.S., but 80% of electricity in China comes from coal.
Jim Rogers, the CEO of one of America's largest electric utilities, says figuring out how to clean up coal must be part of the solution.
The issue becomes, can we clean it up? That is the technology challenge we have, because you just can't wake up and tomorrow morning and say, no more coal. Not going to happen.
Rogers says we need to be finding ways to capture and store carbon, like Lackner is doing in his lab, but on a very large scale.
We need to do it with a sense of urgency. We're not moving fast enough.
The process of capturing carbon and burying it is happening on a massive scale, in a place where people don't take taxis. They take camels. The Sahara Desert, Algeria. A location so remote and difficult to get to, we had to fly there on British Petroleum's chartered flight from London. Insala was once an important trade link in the middle of the Sahara Desert. Today, it may be an important link to our energy future. North Africa is rich in natural gas. At Insala, that gas, which might heat your home and fuel your stove, comes out of the ground with up to 10% carbon dioxide mixed in, an impurity that would make your stove burn less efficiently. So the carbon dioxide is scrubbed out, like in a submarine. Usually that carbon dioxide is just released into the atmosphere. But here at Insala, it is pressurized and pumped through huge pipes that stretch across the desert. "5 miles away, the gas makes an unexpected turn. Here at the KB502 site, the Algerian National Gas Company and BP are putting the carbon dioxide right back where they found it, underground. Geologist John Midgley is checking up on the gas pressure.
This is the injector wellhead for KB502. In this pipe is the carbon dioxide that's been compressed at the production facility. The noise you hear is the flow of gas.
The pressurized carbon dioxide is then forced more than a mile below the surface. where it is pushed into a porous rock formation and effectively trapped back underground.
That facility takes a power plant's worth of CO2 and injects it deep under the earth.
In the wedges game, capturing the CO2 like this from 1,600 natural gas plants would provide one wedge, or 1/7 of the needed solution. But doing this is expensive and would increase the price. So at present, Nsala is one of only 4 such facilities in the world operating at a large scale.
There aren't more of these right now because there's no commercial reason to do them. If the price of fossil fuel reflected the damage that was caused by the greenhouse gases, then all of a sudden there would be an economic reason to store the carbon dioxide below ground.
Given that the gas is invisible, how do they know it is actually staying underground? Satellite measurements reveal the surface of the Earth at the site actually moving.
We can calculate how much movement there is in the Earth's surface after we've backed out calculations for Earth tides, planetary motions.
The sands of the Sahara are stretched up to 12 millimeters to make room for the carbon dioxide injected inside. So if carbon dioxide from a single natural gas plant can literally move the surface of the Earth, what is the impact of all of the carbon our modern life creates? We produce 9 billion tons of carbon a year, a number so hard to fathom that we decided to break it down into something more manageable and personal. What is your contribution to climate change?
When you look around your home, there are some obvious places where we use a lot of energy and for most people generate a lot of carbon.
Dan Kamen of University of California at Berkeley has tried to figure out the carbon footprint of the average American. Heating our homes, driving our cars, growing and shipping our food.
We know how much carbon is associated with each unit of energy we use in our house. Adding those things up is basic accounting.
Kamen developed a website where you can calculate your carbon footprint. But we wanted to make it a bit more graphic. So we asked him to imagine it as a solid, like garden compost, which is mostly carbon anyway. 1 pound of carbon emitted as an invisible gas can be represented as a pound of this rich black dirt.
A 20-mile trip to the store and back, that's about 6 pounds of carbon.
1 short trip, 6 pounds. But in 1 year, the average American drives about 10,000 miles.
This is the average American's driving for the year. 2 tons of carbon.
All those car trips, 2 tons. And all that driving, flying, buying, and heating we do in a year?
6 tons. And to show you the average family's carbon footprint, I've invited my kids to join me. And this is the average American family's carbon footprint for just 1 year.
Your average family's 14 tons of carbon waste combines in the atmosphere with oxygen to create 50 tons of carbon dioxide gas. That gas floating in the atmosphere lets sunlight enter to warm Earth. but it blocks much of the heat from escaping. It's like an invisible Gore-Tex blanket warming our Earth. So how can we get energy with the least amount of carbon emissions? First up on everyone's green energy list, the sun. Solar power is the poster child for transforming our energy system.
There's huge potential. If you look at the numbers, the amount of solar energy reaching the surface of the Earth is 100,000 terawatts. And the amount of energy that civilization is using for all of its purposes today is 17 or 18 terawatts. This makes solar energy enormously attractive.
You know, you only need a few square meters of solar panels for every person in the world to actually generate all the energy of the world. And the reason we don't do that is it's still too expensive. Solar panels cost a lot of money. The question is, can we make photovoltaics cheap?
Making solar power cheaply is now the goal. And with billions at stake, there is a race on to do it. There is no better place to see the intensity of that race than here in China. China leads the world in the manufacture of solar panels. And it's not just because of cheap labor. A big part of it is down to this man, Zheng Rongxi, the CEO of Suntech, and a remarkable rags-to-riches story.
People think you get a fortune overnight, but I never believe that. I mean, it's not true for anybody. It's not true, unless you have a rich father. You know, I mean, that's different. You know.
Xi's family was far from rich. In fact, his father was so poor that Xi was put up for adoption. Now, he is known as the Sun King and is ranked among the richest men in the world.
I'm a very aggressive personality. So when I saw there's opportunity building solar, I just moved very quickly.
Before hitting the jackpot, Xi was a solar scientist in Australia, but felt the best way to get solar out to the world was not through publishing papers, but through combining science with business. The initial reaction from his university colleague and teacher, Stuart Wenham, was not encouraging.
Well, to be honest, when he first mentioned to me his idea, I didn't actually think it was a good idea, and I told him so.
Today, Xi's former teacher is his chief technology officer. Instead of perfecting technology in the lab, they are using their science to cut the cost of solar. The base science of photovoltaic technology is pretty straightforward and has been around since the 1950s. Photo means light. And so a photon of light hits an atom, its energy knocks the electron loose, which is then directed through the silicon to the cell. That stream of electrons is electricity that can power anything from your toaster to your TV. During the manufacturing process, metal lines work as wire are put on the surface of silicon.
And the problem is, these metal lines cannot be made very narrow. That shades quite a bit of the solar cell surface.
One way Wenham and Xi are working to improve their cell is by making the wires and close together so the electrons don't have to travel far.
If you look at the solar cell here on my left, of course the metal lines are a lot closer.
The new design increases efficiency, which drives down the costs. It's innovations like these that has led Xi to dominate world production. In 2001, it would take Suntech a whole year to produce what now rolls out of the factory in 2 days. Growth can be seen across China, where they're adding the equivalent of a city the size of Chicago every 3 months. Nowhere is the enthusiasm for solar power more spread than in Zhou, 3 hours south of Beijing. At night, the city is alight with neon. That is powered by batteries. Charged in the day, by an enormous array of solar panels. The man behind this showcase city is Huang Ming, another of China's solar millionaires.
Solar Valley is my dream of nuclear landscape or lifestyle.
Now Huang Ming wants to spread his wealth and passion for solar around.
Ming has been possessed by his vision to design a community which in fact was 88% solar reliant.
Oil shell. While it may be flashy, he says it's emblematic of China's growing prosperity.
You know, in China today, you see the most amazing things springing up. In some sense, they're very impressive, involving a lot of very innovative technology. And there are these weird other aspects of them. But there is this extraordinary dynamic energy that sort of bursts forth.
And it's not just China. The energy problem is seen as a problem all over the world.
China is moving very aggressively. India is moving. Western Europe is beginning to move on. Even some oil exporting countries, OPEC countries, are beginning to realize that you need to develop cleaner energy sources.
Since coming to the Department of Energy, Secretary Stephen Chu has increased spending on developing clean energy by $40 billion.
You need technologies. Solar power, wind power, carbon capture. Who's going to supply the world with those technologies? I would hope it's the United States.
The U.S. once was enthusiastic about solar, at the height of the oil crisis in the 1970s.
By the end of this century, I want our nation to derive 20% of all the energy we use from the sun.
To great fanfare, President Jimmy Carter even installed solar heaters on the roof of the White House. But a few years later, after oil prices dropped, Ronald Reagan took the panels down. Today, America is trying to get back into the solar game.
I mean, the bottom line is we roughly want to double the amount of clean energy.
The goal for Secretary Chu is to double the amount of non-carbon emitting energy in the U.S. by 2035.
Come back here.
And a large chunk of that is solar.
Along comes a need. We need clean energy. This is a problem that science can solve. That opportunity is huge. The dominance in certain areas.
The idea is to invest in science that will pay off in practical solutions. One of the major